today's video, we're going to go ahead and take a look at the slider joint 2D. So I've got my red bar selected. I've got a rigid body and a box slider on it. So I'm going to go ahead, just add that slider joint. There we go. And let's take a look at just the default settings, see what's going on here. So I'll start it up and it falls down and collides with this rigid body. We went ahead and moved this out of the way. It'll just jump straight down and keep going. Let's go ahead and select it again. And notice we do have a green line leading to it. So what's going on? Well, let's take a look. So the first thing we'll take a look at is the enable collision. Now, if we go ahead and check this and it is not connected to any other rigid body, it's going to collide with other colliders in our scene. So if I go ahead and start this, it should stop when it hits this. There we go. And of course, as we've seen before, without it checked, it's going to go right through. Now that behavior changes when we go ahead and connect it to a rigid body. I'm going to take this polygon, which has a rigid body on it. And now when I do it, it automatically collides as well, even without the enable collision checkbox checked. I'm going to go ahead, get rid of the connection, and we'll come down to the next one, auto configure connection. That refers to the anchors here. If we go ahead and select it, it puts both of them at the same spot, which is going to be at the pivot point of your game object. And just like the others, the one inside refers to the connected anchor. And if it's not selected, we can go ahead and move this around. And of course, the one that was on the outside refers to the anchor, which is the one that's connected to the game object that has the joint. So what if we did it this way? We just went ahead and left them connected and started it up. It's just going to sit there. But if we run into it, it moves. And it's just going to keep going in one direction. And I am going to go and enable that collision. And we can hit it. It stops. We can jump on it. We can ride it a bit. So it does move from left to right. And that is because of the next parameter, connected angle. We can adjust it with it set the way it is. It's going to automatically configure based on what it's connected to. And right now we have both points at 0, 0, or the center of this game object, I should say. So if we went ahead and unconnected the auto configure angle, we can now type into this. And honestly, if you go any angle besides 0 or 180, it will move on its own. And that's because it's slowly falling down. So because it's at 1 degree, which is just a slight incline, it starts to fall down. Of course, we can still ride it and everything else and push it around, but it's got a little bit of momentum. That, of course, could be exaggerated if you went ahead and did something like 270. Now, these angles, 0 is to the right, 180 is to the left, and 90 is up, 270 is down. So if I type it in 270, and if I went ahead and started, it's just going to fall straight down, but it will collide because I have this here. And of course, just for example, I just want you to see that it does fall all the way down. And away it goes. Well, we can counteract that with the next parameters. Let's take a look at those, which is the motor. So in order to use these motor parameters, we have to go ahead and enable the use motor checkbox. Then we can go ahead and add a speed. This is just how fast it's going to move. I'm going to start it off slow, maybe a 1. And then we have a maximum force. This is how much force is going to push it in that direction. Let's go ahead, we'll start it up. We should have actually started left and right first, but we didn't. But take note that it pushed all the way up until it collided with that. We can still interact with it. We can jump on it. And if we went ahead and lowered the force, which I'm going to do next, let's put it down from 1,000 to 80. It can go up to 1,000,000. But really, you're just going to be adjusting this force to get the feeling that you want for your game. A couple of the other ones were 80. There we go. So we can get a little bit of a bounce, like a spring. And it will not go below this point here as far as the joint goes. Let's go ahead. We'll lower this down to say 50. And now when they get back to this original position, it'll just stop. Then, of course, depending on how much force is being applied downwards, it will depict how jerky that stop is. Oh, we haven't actually gotten to the translation limits. When we get there, that's when that happens. Without it, it just goes down and starts pulling back up. I'm already getting ahead of myself. Okay, we'll go ahead, we'll stop that. And now we're going to look at translation limits, which limits how much movement you can have. So of course, to use that, we've got to tick the use limits box. And to make it a little bit more easy to understand, I'm going to go ahead and tick the auto configure connect, and I'm going to move down on the Y a bit. No, I said down. And then on the lower translation, let's set that to -1. So there we go up here. And the upper, let's set it to 1. So now we have a limit of where we can move. So if we went ahead, let's move the thing out of the way. Grab this, I want to move it over here a bit. And now we have that angle, which I don't want. Like if we jumped on this, instead of moving directly up and down, it's going to move on that slight angle. I don't want that. So what I'm going to do is just go ahead, make it in the center again, untick it, and move it down. Let's put the force back up to 80. And there we go. We have our minimum and our maximum defined. So if we jump on it, let's still go down. It can go down a little bit. So I guess we should actually leave it at 50. Let's even really bring it down to 30. That might be too much, but let's demonstrate. It can go down to, well, where this touches this is where it starts. Then as far as the compression goes, it can go as far as where this one touches down here. There we go. Of course, as soon as we get off, it goes back up. And there are other things we can do with it too. Like let's put this to 1. Let's put this to 2. Let's put it underneath us. There we go. And it pushes up by default. And it works just like before. Except now here's the range that it has to move. I'm going to put it back up to 80. I'll move it up a bit. Let's take this, move it back down. Maybe even on a slight angle. That's fine. What I'm going to do now is set it to be the connected rigid body. And just like we showed before, if we didn't have this enabled, let's make it really soft again. I'm going to turn off limits. With the enable collision not checked and it being connected to a rigid body, if we jumped on it, it's going to slide down into it. Oops, let's turn off that motor because we don't have limits defined. Actually, let's just bring it down a bit and we'll just jump on it even with the motor. That's fine. Come all the way down and it goes through the rigid body, but it collides with this one over here. Let's say we didn't want it to collide with the rigid body like we explained before. We go ahead, we take the enable collision, and now it's going to collide with what it's parented to. Or I keep saying what it's parented, what it's connected to. Great. So I'm going to go ahead, stop that. I'm going to enable the limits again. I want to go ahead and increase that force back up to 80. I thought that was good. And let's take a look at these last parameters, the brake force and brake torque. Now, if there's ever too much force applied in any one direction, this joint will break and it just falls off and goes somewhere. Same thing with torque. If it gets twisted too much in any one direction, it'll break off and just will break the joint. So let's start off, I don't know, is it 32 little for torque? So it's just sitting there hanging out and I come jump on it and I added too much torque and it breaks. To get back up to infinity, we just type in INF. And let's do brake force. Let's try maybe 100. That might be too much. We'll find out. Yeah. Not enough to break it. Let's bring it down a bit. 90. How much force can we handle with just us jumping on it before it breaks? Well, it's got 80 pushing up. Let's try 50. And there we go. And of course it breaks and falls off and floats away. So with that done, let's go ahead. We'll take a look here. I think we've covered everything about this, right? We've enabled the connections. We've connected. We've looked at the anchors, played with the angles, the motor, the translation limits, and now the brake force and torque. All right, there you go. I kind of like this one simply because you can have moving conveyor belts. You could quite simply have it moving side to side with your motor and then detecting when you collide with something. Let's quickly do a demo of that. And have that floating platform with very little code. I'm going to move on 0. I'm going to go ahead, set it there. We don't want limits. I am going to go with the motor though. Let's go with something a little quicker though. Let's try a 5. And if we go ahead and start this up, let's fix that brake force. And we'll start this back up and away it goes. And I'm still good enough to be able to push it. Unfortunately, it got me cornered. Let's go to -5. Make it go the other way so it's not colliding with me right away. I guess I could have just lifted it up a bit as well. 5's too quick anyway. I guess 1 was better. So we'll go ahead, we'll start it up, and we can just jump on it. Now, of course, when we jump on it, we could be either just parent ourselves to it. We might just be able to increase the friction to drag us along as well. But when it goes ahead and collides with this wall over here, we could quite simply just have a script that detects when it collides with it, and then just multiply the direction by -1. Which will just make it go this way here again. And when it collides over here, multiply it by -1 again. And hey, look at that. You've got this platform that can't be really affected by anyone jumping on it or anything like that. Well, you can still push it. And if you don't want that behavior, you can really just jack up the force. But anyway, we've covered all of the properties of it. What are you going to use it for? I'd love to know down below in the comments. And as always, I'll see you in the next video. Bye-bye. So if you like the video, go ahead and hit that subscribe button down below. It really does help me out here on YouTube. And go ahead and follow me on Twitter. I can be a pretty chatty guy over there when I'm not walking through a forest or being stalked by eagles and falcons, lions, tigers, and bears.